Alright, video 3. Let's see how you guys get on with this. So things get a bit harder now. We're going to look at analog inputs, which are ones that can have a range of values rather than just being on or off like the last challenge we did with the switch. So again, you'll need the PowerPoint. You're going to be hooking up 8 LEDs, which you should be quite happy with now. So basically every one of your outputs is going to have an LED wired up to it as per this. But you're going to be using an analog input now, so that comes under analog inputs. There we go. And I think you're using a light dependent resistor, so you need to hook it up like this. Read the instructions. This can only be connected to an input with an A in the title, so that would be 2 has got an A in it, 1 and 0 have got A's in them. If you try and hook up your LDR circuit to 7 or 6, it will not work because those 2 inputs on the PIC chip can only handle digital, i.e. on and off signals. So hook it up to whichever one you like. Now you've got a bit of a helping hand here because I've done part of the circuit for you. I'm going to hook my LDR circuit up to analog input 1. Right, now before I show you the flowchart, I'm going to show you some things on this. Actually no, it won't do anything yet. Just alright, I'm going to have to sort of flick back and forth between these 2 screens to show you what I mean. Okay, so right, I've just, hold on 1 second, I think I've put the wrong, alright, yep, ignore my little I've just noticed there's a mistake in here. See, I want an LED. You don't actually need the LCD command on this PowerPoint. That's a lie. I'm copied and pasted by mistake from the last one. Alright, so you're just going to need outputs and analog basically. Anyway, so in the flowchart, go and find yourself the analog button, stick it in, and like most things, double click on it, and what you get is check analog sensor. Now what that's asking you is which of those 3 inputs did you hook your sensor up to. So if we go back to our challenge, I chose analog 1, you might have picked 0 or 2, it's whichever one you chose. So I'm going to choose analog 1. Okay. Now rather than before with the digital box, just to remind you, you could either choose an input as being on or off, nothing in between. With an analog input, you've got this slider bar here which represents a range of values. Now what the PIC chip does is it measures voltage coming in on that pin, and because it's based on a computer, you might have heard computers work in bits, so you might have heard of 8, 16, 32, 64, 128, 256 bit. That's what it does, is because that's how kind of computer memory and processing works. It measures the voltage coming in here and divides it between 0 and 255 different lumps. Okay, that's all it can do. It's called an analog to digital conversion. What it's doing is taking that reading that can vary between any minimum and any maximum and splitting it into 255 segments. It's not 256 because that would cause, I don't want to talk about it, don't worry about that. But the number 255 comes from that kind of computer processing gibberish, you know, 8, 16, 32, 64. Anyway, I'm waffling a bit, ignore what I'm talking about. So it's splitting it into those individual intervals, and what we can do is we can say, like on the digital box we had a yes or a no path, we can have a yes or a no path with analog, but instead we're looking for a range of values. So what I'm going to do to help you is write a simple program that will, if the light sensor's in one range, it's going to turn my LED on, and if it's in another range, it's going to turn it off. So I'm going to slide my slider bar. You can type the numbers, by the way, if you wanted. So let's go 125. Okay. I'm going to put in a caption, is LDR in the range 0 to 125, is what I'm asking. And treat it like the decision box in the last one. Now I hooked up my LED to output 0, so if it is in that range, I'm going to turn on output 0. Remember your captions. And if it's not in that range, then I'm going to turn off output 0. That was off. I apologise for my voice, by the way. I've got a hell of a cold at the moment. So if I sound even more monotonous and boring than normal, you know why. It's my cold. By the way, I heard that some lovely person put a picture of me up in the sick form smiling. That was nice to hear. Nice to know that when I smile it's that rare of an occasion that people feel the need to photograph it. You should try being a teacher for 7 years, then you'll realise what it is to not smile. Right, here we go. So I've hooked that up. If I press play and I do that on the challenge here, it should work. Now, what I'm going to do, I'm going to close that. I'm going to look at a different screen. I'm going to click on View the Analog Sensor Readings. That's quite useful. So at the moment, this little slide bar, by the way, represents the amount of light shining on our LDR. That would be maximum light. That would be no light. But what I want you to pay attention to is this number over here. Okay. Can you see, as I increase the light, the number goes up. Full light gets almost all the way to 255. No light goes all the way down to 0. Now, if you remember in my flowchart, the magic number was, if the LDR is in the range of 0 to 125, if that is true, then go and turn the light on. So if we look at this just to confirm, at the moment it's 71. That is in the range, 0 to 125, so my light is on. Okay, and I can creep up, light's still on, 105, 13, 122. As soon as I cross that threshold to 127, it turns off. Okay, and again, just to show you, if you put the flowchart alongside it, zoom in a little bit more. Here we go. Same thing's working. Okay. So there we go. Different values give a different result. So this is the basis of what you're going to be doing for this challenge. Now you're going to have to expand this. I want you to hook up 8 LEDs, and basically I want you to divide your light sensors readings into 8 different ranges. Okay, so you're going to have to split that magical, you might have to do a bit of maths to figure this out. Your whole entire bandwidth, if you like, is 0 to 255. You're going to have to split it into 8 segments, and you're going to have to check each segment and see if the light sensor is in that range, and if it is, then you want to turn on a different number of LEDs. So the essential thing I want to happen, I'm just going to pause the video while I go and find the solution, because otherwise you could cheat. Alright, I'm back. That will have appeared like no time at all to you, but that actually took several minutes. Right, so you got a sneak preview on how you could hook it up here. But this is what needs to happen. Go away, don't want to share that. Right, basically when there's no light, I only want one LED lit, and the more light that comes along, the more LEDs I want to come on. So effectively what we're building here is a light meter. You could actually make a project out of this. This could be like for photographers, for like a little handheld display to detect how much light there is so they can adjust the settings on their camera. It could just be some clever mood lighting. You could actually make it work the reverse way around, so the darker it got, the more lights come on. So it could be like a staged night light or security light, but that's what your program's got to do. I thought it's just easier to show you that than it was to try and talk it to you. Okay, so my only advice, no, don't want to see that, that was cheating. You're going to need many different analog boxes, but it's how you hook them up and how you link them together that's the challenge. Alright, that's the end of video 3.